Now, in this lecture, we'll find out the radius of the circle. In the drawing, we have a big semicircle. Inside this big semicircle, we have two semicircles and one circle. We also know that this line segment equals to 140 units in its length, and this line segment equals to 70 units in its length. And our mission is to find out the radius of this circle. Okay. So first of all, we will define the relevant points here. We'll define this point as A. The center of this semicircle will define as B. We'll define the center of the biggest semicircle, this point as O. We will define the touching point of this semicircle with this semicircle as C. We will define the center of this, the smallest semicircle as D. We define the touching point of the smallest semicircle with the biggest semicircle as E. We will define the center of this circle as F. We will define the touching point of this circle with this smallest semicircle as H, and we define the touching point of this circle with this semicircle as G, and we define the touching point of this circle with the biggest semicircle here at this point as I. And we will also define the radius of the biggest semicircle as capital R, and the radius of this small circle as R. So I write it down. Capital R is the radius of the biggest semicircle, is the radius of the biggest semicircle, and small r is the radius of the circle, that's the radius that we are looking for. The radius of the circle. Okay. Actually, it is given us the question that the length of line segment AE is equal to 140 units plus 70 units. Okay, so AE equals to 140 units plus 70 units, it is actually equals to 210 units. AE equals to 210 units. But what is the definition of line segment AE? AE is the diameter of the biggest semicircle. and the diameter of any circle or semicircle is twice as long as the radius. That is to say, AE must be equal to 2 times the radius of the biggest semicircle. That is to say, AE equals to 2 times capital R. AE equals to 2 times capital R, that is the radius of the biggest semicircle, and we have already found out that A equals to 210 units. From this equation you can conclude that 210, or the 2R equals to 2 times capital R equals to 210. Here we'll divide this equation by 2 and we'll get that capital R, the radius of the biggest semicircle, equals to 210 over 2, that is 105 units. The radius of the biggest semicircle equals to 105 units. Capital R equals to 105 units. So here, O is the center of the biggest semicircle. A is the point of the biggest semicircle itself. Therefore, OA, this is the definition of a radius. OA is the radius of the biggest semicircle that is equal to 105 units. Likewise, O is the center of the biggest semicircle. AE is the point of the biggest semicircle itself. Therefore, OE, it is also the radius of the biggest semicircle that is also equals to 105 units. Likewise, it is given us in the question that line segment AC equals to 140 units. But what is actually line segment AC? Line segment AC is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius of this semicircle must be equal to half of it. That is to say, 140 over 2, it is 70 units. So AB, that is the radius of this semicircle, equals to 70 units. And BC, it is also the radius of this semicircle, it is also equals to 70 units. Likewise, it is also given us in the question that the length of this line segment CE, it is equal to 70 units. CE is the diameter of this smallest semicircle, and because of the fact that the diameter of this smallest semicircle equals to 70 units, it means that the radius must be equal to half of it. That is to say, the radius must be equal to 70 over 2, that is 35 units. So DE, that is the radius of the smallest semicircle, equals to 35 units. And CD, that is also the radius of the smallest semicircle, equals to 35 units in its length. Okay, what is the length of line segment OB? The length of line segment OB, it is very easy to see from the drawing that OB equals to OA minus BA. Again, OA minus BA equals to BO. So I write it down. BO equals to OA minus BA. Repeat again. The length of line segment BO, it is equal to OA minus BA. So BO equals to OA. We have already found out that the OA is the radius of the biggest semicircle that is equal to 105 units. So we substitute OA by 105 units minus AB. We have already found out that AB or BA equals to 70 units. So we substitute BA by 70. And finally we will get that BO equals to 105 minus 70, it is 35 units. So we found out that line segment BO equals to 35 units. So I write it down here that BO equals to 35 units. You can write down in the drawing itself that BO equals to 35 units. VO equals to 35 units. And what is the length of line segment OC, the small line segment OC? From the drawing, it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. I write it down. OC equals to OE minus CE. Repeat again. The length of line segment OC, it is OE minus CE. So OC equals to OE. We have already found out that the length of OE is the radius of the biggest semicircle. That is to say, it is equal to 105 units. So we substitute OE by 105 minus CE. We have already found out that CE is actually given us in the question that CE equals to 70 units. So we substitute CE by 70. In conclusion, we found out that OC equals to 105 minus 70. 105 minus 70 is 35 units. So OC is also equal to 35 units. So I write it down that OC equals to 35 units in its length. Okay. In the next step, I will present to you two new rules, and we will implement the two new rules in our drawing. We actually have rule number 10. According to rule number 10, if two circles are touching each other internally, like in this drawing, the small circle is located inside the big circle and it touches the big circle at point N. So in this drawing, the two circles are touching each other internally. There is an internal length between them. Then the straight line that connects their centers together, the center of the big circle is at point O. The center of the small circle is at point M. And OM is the straight line that connects their centers together. The straight line OM must pass for their touching point, that is to say for point N. And because of the fact that the straight line OM must pass for point N, it means that OMN is one straight line. OMN is one straight line. And what is the distance between their centers OM? The distance between the centers is the radius of the big circle, that is capital R, minus the radius of the small circle, that is actually small r. Okay, here OM equals to capital R minus small r. Capital R is NO, small r is MN, this is small r, and therefore D, that is the distance between their centers, equals to capital R minus small r. D equals to capital R minus small r, so OM equals to capital R minus small r. It is very easy to see that ON minus NM equals to MO. So capital R minus R equals to the distance between their centers. So this difference between their radii, it is the distance between their centers, MO. Likewise, we also have rule number 11. According to rule number 11, if two circles are touching each other externally, here the two circles are not located by each inside the other, but they are touching each other externally at point N. So there is an external knot between the two circles. So the center of the big circle is a point O, and the center of the small circle is point M. And the straight line that connects the two centers together is the straight line OM. And this straight line OM, according to rule number 11, must pass through their touching point. That is to say, it must pass through point N. That is to say, O and M is one straight line. And what is the distance between their centers? OM. What is the length of line segment OM? That is the distance between the centers of the two circles. It is equal to the radius of the big circle, that is capital R, plus the radius of the small circle, that is small r. So the distance is capital R plus small r. Okay. So we can implement the two new rules in our drawing. Okay. So here we will join the center of this semicircle, that is to say point B, with the center of this circle, that is to say point F, together by a straight line. And according to rule number 11, the straight line BF that connects their centers together must pass for their touching points. That is to say, their touching point is at this point, point G. So here, the straight line BF that connects the centers of the two circles together must pass through point G. Okay, the straight line BF passes through point G, that is their touching point. So actually, FGB, it is one straight line according to rule number 11. Point F is the center of this circle, point G is the point on the circle itself, therefore FG is the radius of this circle, that is equal to small r according to our definition. Point B is the center of this semicircle, point G is the point on the semicircle itself, therefore BG is the radius of this circle, of this semicircle, that is equal to 70 units. So in total, the distance between the centers of the two circles, that is to say, the length of line segment BF is equal to 70 plus R. So I will write it down. BF equals to 70 plus R units. The length BF, that is the distance between the center of the semicircle and the circle, it is equal to 70 plus small r units. Likewise, we'll connect the center of this smallest semicircle, that is at point D, with the center of this circle, that is at point F. So the straight line FD that connects the two centers together must pass through their touching point, that is actually point H. So FHD is one straight line. FHD is one straight line. And what is the length of FD, that is the distance between their centers? F is the center of this circle, H is the point on the circle itself, therefore FH is the radius of this circle, that is equal to small r. Likewise, we have point D, that is the center of this semicircle, of the smallest semicircle. Point H is the point of the smallest semicircle itself. Therefore, HD is the radius of this semicircle, that is equal to 35. Therefore, the distance between their centers FD, it is equal to R plus 35, for 35 plus R units. So FD equals to 35 plus R units. Repeat again, FD, the distance between the centers of the circle and the smallest semicircle, is equal to 35 plus R units. Likewise, we will find out the distance between the center of this semicircle and the smallest semicircle. That is to say, the length of line segment BD. BD, for a drawing it is very easy to see that BD, here, BD BD, here it is small d and this is capital D, so BD equals to 35 plus 35 plus 35 units. Again, BD equals to 35 plus 35 plus 35 units, that is 105 units. So this is actually point O. This is point O. That is the center of the biggest semicircle. And this is point D. This is point D. Point D is the center of the smallest semicircle. So BD equals to 35 plus 35 plus 35, that is 105 units. BD equals to 105 units. We will join the center of the biggest semicircle, that is to say point O, with the center of this circle, that is at point F. So the biggest semicircle and this circle have an internal notch between them at point I. That is to say they are touching each other internally at this point, point I. And therefore, according to rule number 10, the straight line OF that connects their centers together must pass through their touching point, that is actually point I. So OFD or OFI, this line segment OFI, it is one straight line. OFI is one straight line. So here, point I, point F is the center of this circle, point I is the point on the circle itself, therefore Fi is the radius of this circle that is equal to R. And what is the length of line segment FO? From the drawing it is very easy to see that FO equals to OI minus FI. Again, OI minus FI equals to OF. FO equals to OI minus FI. Okay, again, OF or FO equals to OI minus FI. So OF equals to OI. What is the definition of line segment OI? O is the center of the biggest semicircle. I is the point on the biggest semicircle itself. This is exactly the definition of a radius. So OI is the radius of the biggest semicircle, that is equal to 105 units. So OI equals to 105 minus Fi. Fi is the radius of this circle, that is equal to small r. So in conclusion, we found out that OF equals to 105 minus r units. Okay, here you can find out that line segment FO or OF equals to 105 minus r units. Okay, so in the next step I will present to you a new rule, and we will implement the new rule in the green triangle FBO. This green triangle FBO. The new rule is called Stewart's Theorem. Stewart's theorem is true in any triangle. So the triangle that I draw could be any triangle. This is triangle ABC, that could be any triangle. And you actually know that the length of side AB is equal to side AB equals to A units in its length, side AC equals to B units in its length, and finally side BC equals to C units in its length. And we have line segment AO. Line segment AO equals to D units in its length. BO, the length of line segment BO equals to M units, and line segment OC equals to N units in its length. Then according to Stewart's theorem, the following equation will be true, that A squared times N plus B squared times M, it is equal to C. C is the length of side BC. We will open brackets here. Inside the brackets we have here D squared. This is the length of line segment AO. D squared plus M times N. Okay, this is Stewart's theorem that is true in any triangle. Therefore, we can implement Stewart's theorem in our triangle, triangle BFD. So, in any triangle, A squared times N plus B squared times M equals to C. Inside the brackets, we have D squared plus M times N. We will implement Stewart's theorem in our triangle, triangle FBD. So I'll copy triangle FBD in the new page and we will implement on it Stewart's theorem. Line segment FD equals to 105 times R units in its length. AB equals to 70 plus R units in its length. FD equals to 35 plus R units in its length. And BD equals to 105 units in its length. BO equals to 35 units in its length. And OD equals to 70 units in its length. So actually, this is triangle FBD. This is a copy from the original drawing. according to Stewart's theorem. In this triangle FBD, we'll get that FB square times OD, FB square times OD plus FD square times BO is equal to BD, and inside the brackets we have FO square plus BO times OD. This equation is the implementation of Stewart's theorem in our triangle FBD. Again, FB square times OD plus FD square times BO equals to BD, and inside the brackets we have FO square plus BO times OD. So FB is 70 plus R, therefore FB square is 70 plus R square times OD. OD is 70, so it is times 70 plus FD square. FD is 35 plus R, therefore FD square is 35 plus R square times BO. BO is 35, so we substitute BO by 35, and it must be equal to BD. BD is 105, so we substitute BD by 105. Inside the brackets we have FO square. FO equals to 105 minus R, therefore FO square equals to 105 minus R square plus BO times OD. BO is 35 and OD is 70, so it is 35 times 70, all inside the brackets. So here we'll substitute 35 by x. According to our definition, 35 equals to x, and whenever we have in the equation, this equation, Stewart's equation, 35 for any multiplication of 35, we will substitute it by x, and we'll get that here we have 70. 70 is 35 times 2. 35 times 2 is 2x, or 2 times 35 is 2x, plus R square times 70. 70 is 35 times 2, or 2 times 35, that is to say it is 2x. So in conclusion, this expression 70 plus R square times 70 is 2x times 2x plus R square plus 35 is x, so we substitute 35 by x, it is x plus R square times 35 is x, so we substitute 35 by x, and it is equal to 105. 105 is 35 times 3, or 3 times 35 is 3x, so we substitute 105 by 3x. Inside the brackets we have 105, that is 3x, minus R square, plus 35 is x, and 70 is 2x, so it is x times 2x, all under the brackets. So we got this expression by substituting 35 by x, we got this equation. Here we will divide this equation by x, and we get that here x will get cancelled, and we're left only with 2 times 2x plus r squared, plus x will get cancelled here, and we're left only with x plus r squared, and it is equal to, here x will get cancelled, and we're left only with 3. Inside the brackets we have 3x minus r squared, plus x times 2x is 2x squared. Okay. So here we will open the brackets. This 2 times 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared, plus 2 times 2x times r is 4xr, plus x plus r squared is x squared, plus r squared, plus 2 times xr, and it is equal to 3. Inside the brackets we have 3x minus r squared is 3x squared, that is 9x squared, plus r squared minus 2 times 3x times r, it is minus 6r. Plus 2x squared, all under the brackets. Here we'll open the brackets. 2 times 4x squared is 8x squared, plus 2 times r squared is 2r squared, plus 2 times 4xr is plus xr, 8xr, plus x squared, plus r squared, plus 2 times xr. And it is equal to, here we have 3. Inside the brackets we have 9x squared plus 2x squared is 11x squared. And here we have r squared plus 2r squared is 3r squared. And here we have minus 6xr. So in this side of the equation we have 8x squared plus x squared is 9x squared. We have 2r squared plus r squared is 3r squared. And 8xr plus 2xr is 10xr. And it is equal to 3 times 11x squared is 33x squared. And here we have actually 3 times r squared is 3r squared. So it is, here we have 3 times r squared, that is plus 3r squared. And we have also 3 times minus 6r, that is minus 18xr. Okay. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we subtract 9x squared from this equation, and we get that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. That is equal to 33x squared minus 9x squared is 24x squared. minus 18xr. Here we will add 18xr to this equation, and we'll get that 10xr plus 18xr is 28xr, that is equal to 24x squared. So we found out that 28xr equals to 24x squared. Here we will divide this equation by x, and we'll get that 28xr over x is 28r, that is equal to 24x squared over x is 24x. In conclusion, we found out that 28r equals to 24x. Here we'll substitute x by 35, and we'll get that 28r equals to 24 times x is 35. So in conclusion, we found out that 28r equals to 24 times 35. Here we will divide this equation by 7, and we'll get that 28 over 7 is 4, so in total in this side of the equation we have 4r, that is equal to 24 times 35. 35 over 7 is 5. In total, in this side of the equation we have 24 times 5. Here we will divide this equation by 4. 4r over 4 is r, and 24 over 4 is 6. So in this side of the equation, in total we have 6 times 5. So r equals to 6 times 5. 6 times 5 is 30. So r equals to 30 units. So the answer to our question is that the radius that we are looking for, that is the radius of this circle r, equals to 30 units. Okay. In the next step, I will summarize the lecture. So in the drawing we have big semicircle. Inside this big semicircle we have two semicircles and one circle. We know that line segment AC equals to 140 units and line segment OE equals to 70 units. Our mission is to find out the radius of this small circle. Okay. So first of all, we defined the radius of the biggest semicircle as capital R, and the radius of this circle, that is the radius that we are looking for, is small r. Then we gave names to the relevant points: A, B, O, D, and E. The center of this circle is at point F. The touching point between the biggest semicircle and the circle is at point I. Point O is the center of the biggest semicircle. And the length of line segment AE, according to what is given as the question, it is equal to 140 units plus 70 units. 140 plus 70 is 210. So here line segment AE equals to 210 units. Line segment AE equals to 210 units. But what is exactly line segment AE? What is actually line segment AE? AE is the diameter of the biggest semicircle. And because of the fact that the diameter of this biggest semicircle equals to 210 units, it means that the radius must be equal to half of it. So the radius of this semicircle that is defined as capital R will be equal to 210 over 2, that is 105 units. Yeah. The diameter of any circle is 2 times the radius, therefore AE, that is the diameter, it is equal to 2 times capital R. And we already found out that A equals to 210, so from this equation we can conclude that 210 equals to 2R. Here we divided this equation by 2 and found out that R, the radius of the biggest semicircle, equals to 105 units. So AO, that is the radius of the biggest semicircle, it is equal to 105 units. And OE, that is also the radius of this biggest semicircle, equals to 105 units in its length. Okay. Likewise, it is given as the question that 9 segment AC equals to 140 units, but AC is the diameter of this semicircle, and therefore the radius must be equal to half of it. That is to say, the radius AB equals to the radius BO equals to 140 over 2, that is 70 units. Likewise, we know that the diameter of this smallest semicircle, CE, equals to 70 units according to what is given in the question. Therefore, the radius must be equal to half of it. So the radius CE, the radius CD is equal to the radius DE equals to 70 over 2, that is 35 units. Then we found out the length of line segment BO. BO equals to OA minus BA. OA is 105 units, this is the radius of the biggest circle, minus BA, that is 70 units. So OB equals to OA, that is 105 units, minus BA, that is 70. 105 minus 70 is 35. Therefore, BO equals to 35 units. Then we found out the length of line segment OC. The length of line segment OC from the domain is very easy to see that OC equals to OE minus CE. OE minus CE is the length of OC. OE is 105 units, it is the radius of the biggest circle. CE is 70 units. This is the diameter of the smallest semicircle. So OC, it is 105 minus 70, that is 35 units. So OC equals to 35 units in its length. Okay. Then I presented to you 2 new rules, and we implemented the 2 new rules in our drawing. According to rule number 10, if 2 circles are touching each other internally, like in this drawing, the small circle is located inside the big circle, and it touches the big circle is point N. Therefore, those 2 circles are touching each other internally. There is an internal notch between them, and they are touching each other internally at point N. So, whenever 2 circles are touching each other internally and there is an internal notch between them, then the straight line that connects their centers together, the straight line, the center of the big circle is at point O, the center of the small circle is at point M. And the straight line that connects their centers together is OM. This straight line OM must pass for their touching point, that is to say for point N. That is to say OMN is one straight line. Okay? And what is the distance between their centers? That is actually MO. The length of MO, it is equals to the radius of the big circle, that is capital R, minus the radius of the small circle, that is small r. Capital R minus small r equals to MO, that is D. So D equals to capital R minus small r. Okay. Likewise, we also have rule number 11. This with the cases that 2 circles are touching each other externally. So here we have if two circles are touching each other externally, those two circles are touching each other externally, that is to say, they are not one inside the other, but they are touching each other externally at point N. N is the touching point between the two circles. Then the straight line that connects their centers together, point O is the center of the big circle, point M is the center of the small circle, and the straight line that connects their centers together is OM. This straight line OM must pass through their touching point, that is to say, it must pass through point N. That is to say, O and M is one straight line. Okay? And what is the distance between their centers? That is to say, what is the length of line segment OM? It is equal to the radius of the big circle, that is capital R, plus the radius of the small circle, that is R. So D, the distance between their centers, OM equals to capital R plus small r. Then we actually implemented the two new rules in our drawing. In our drawing, we connected the center of the smallest semicircle, that is located at point D. This is point D, with the center of this circle that is located at point F. So the straight line that connects the two centers together, that is to say FD, according to rule number 11, must pass through their touching point, and their touching point is at this point, point H. That is to say FHD is one straight line. Okay? So what is the length of line segment FD? FH is the radius of the small circle, HD is the radius of the small circle, that is equal to 35 units. Therefore, in total, FD equals to R plus 35 units. Likewise, we connected the center of this semicircle that is located at this point, point B, with the center of this circle that is located at this point, point F. And according to rule number 11, this straight line FB that connects the two centers together must pass from point D, from point G, that is their touching point. The touching point of this circle with this semicircle. That is to say, FGB is one straight line. And because of the fact that FGB is one straight line, it means that the length of line segment FB will be equal to R, that is the radius of this circle, plus 70, that is the radius of this semicircle. In conclusion, we found out that FB equals to R plus 70 units, FB equals to R plus 70 units, and we have already found out that FD equals to R plus 35 units. Then we found out the length of this line segment BD. From the drawing, it is very easy to see that BD equals to 35 plus 35 plus 35. Okay, 35 plus 35 plus 35, that is 105 units. BD equals to 105 units. In the next step, we connected the center of the biggest semicircle that is located at this point, point O, with the center of this circle that is located at this point, point F. So the straight line that connects the two centers together, that is to say OF, must pass through their touching point, that is actually point I. That is to say OFI is one straight line according to rule number 10. OFI is one straight line. IF is the radius of this circle, that is equal to small r. OI is the radius of the biggest semicircle, that is equal to capital R. And OI minus FI equals to FO. Again, OI minus FI equals to FO. OI is capital R, FI is small r. That is to say, FO equals to capital R minus small r. Okay, here. FO equals to OI minus FI. OI equals to capital R and FI equals to small r. But capital R equals to 105 units, therefore we substitute capital R by 105. In total, we found out that the length of line segment OF equals to 105 minus R units. Then I presented to you a new rule, and we implemented the new rule in our drawing, or implemented the new rule in our green triangle FBD. The new rule, it is called the Stewart's Theorem, and it is true in any triangle. So this triangle, triangle ABC, could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. Line segment AO equals to 2 units in its length. Line segment BO equals to N units in its length. And line segment AC equals to N units in its length. According to Stewart's theorem, the following equation is true. That A squared times N plus B squared times M equals to C. And we open the brackets. Inside the brackets we have D squared plus M times N. Okay, so in conclusion, we found out that according to Stewart's theorem, in any triangle, A squared times N plus B squared times M equals to C. And inside the brackets we have D squared plus M times N. We can actually implement the new rule in our green triangle, triangle FBD. So I copied the green triangle, triangle FBD in a new page, and we implemented on it Stewart's theorem. This is triangle FBD that I copied from the original drawing, and we implemented here the Stewart's theorem. According to Stewart's theorem, FB squared times OD, FB squared times OD, plus FD squared times BO, plus FD squared times BO, equals to BD. We open the brackets. Inside the brackets we have FO squared plus BO times OD. FO squared plus BO times OD. So in conclusion, this equation FB squared times OD plus FD squared times BO equals to BD. And inside the brackets we have FO squared plus BO times OD. It is the implementation of Stewart's theorem in our triangle, triangle FBD. FB equals to 70 plus R, therefore FB squared is 70 plus R squared times OD. OD is 70, so we substitute OD by 70 plus FO squared plus FD squared. FD equals to 35 plus R, therefore FD squared equals to 35 plus R squared times BO. BO equals to 35, so we substitute BO by 35. And it is equal to BD. BD is 105, so we substitute BD by 105. And inside the brackets we have FO squared. FO equals to 105 minus R, therefore FO squared equals to 105 minus R squared plus BO times OD. BO is 35 and OD is 70. Okay, then we defined the number 35 as x, and we substituted in this equation 35 for the multiplication of 35 by x, and we found out that here we have $70 plus R times 2. 70 is 2 times 35, and 2 times 35 is 2x, according to our definition. Inside the brackets we have 70 is 2x, plus R squared, plus 35 is x, so we substitute 35 by x, so inside the brackets we have x plus r squared times 35, and 35 is x, so we substitute 35 by x, and it is equal to 105 is 3 times 35, that is to say it is 3x. Inside the brackets we have 105 is 3x minus r squared plus 35 is x and 70 is 2x. So in total 35 times 70 is x times 2x. Here we divided this equation by x. So here x will get cancelled, here also x will get cancelled, and here also x will get cancelled. So what is left on this equation after we cancelled x? We have 2 times 2x plus r squared plus x plus r squared equals to 3. Inside the brackets we have 3x minus r squared plus 2x squared. Here we open the brackets and we found out that 2 times 2x plus r squared is 2x squared. 2x plus r squared is 2x squared, that is 4x squared. 2x squared is 4x squared plus r squared plus 2 times 2xr, that is 4xr. So in total, the expression 2x plus r squared equals to 4x squared plus r squared plus 4xr, and we have also plus x plus r squared. X plus r squared equals to x squared plus r squared plus 2x, and it must be equal to 3. Inside the brackets we have 3x minus r squared. 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared, minus 2 times 3x minus r is minus 6xr, and we have to add here 2x squared. Here we open the brackets, so 2 times 4x squared is 8x squared, 2 times r squared is 2r squared, and 2 times 4xr is 8xr plus x squared plus r squared plus 2xr equals to, inside the brackets we have 9x squared plus 2x squared is 11x squared, and we have also plus r squared minus 6xr. Okay, so here we have 8x squared plus x squared is 9x squared. We have 2r squared plus r squared is 3r squared, and we have 8xr plus 2xr is 10xr. Here we open the brackets. 3 times 11x squared is 33x squared. 3 times r squared is 3r squared, and 3 times minus 6r, 3 times minus 6xr is minus 18xr. Okay, so here we have 3r squared in both sides of the equation, so 3r squared will get cancelled, and we're left only with, in this side of the equation, we actually subtracted 9x squared from this equation, so 9x squared minus 9x squared is 0. So in this side of the equation we left only with 10xr. In this side of the equation we have 33x squared minus 9x squared is 24x squared, and minus 18xr. So in conclusion, we found out that 10x squared equals to 24x squared minus 18xr. Here we added 18xr to this equation and found out that 10x squared plus 10xr plus 18xr equals to 28xr, and it is equal to 24x squared, because 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. Here we divided this equation by x, and we found out that 28xr over x is 28r, and 24x squared over x is 24x. So in conclusion, we found out that 28r equals to 24x. Then we substitute x by 35, and we found out that (28r) equals to 24 times 35. Here we divided this equation by 7, and we found out that 28 over 7 is 4, so in total this expression equals to 4r. And here we have 24 times 35. 35 over 7 is 5, in total this expression equals to 5 times 24. So in conclusion, we found out that 4r equals to 24 times 5. Here we divided this equation by 4. 4r over 4 is r, and 24 over 4 is 6. So in total this expression equals to 6 times 5. We found out that r equals to 6 times 5. 6 times 5 is 30. So in conclusion, we found out that r, the radius of this circle, the radius that we are looking for, equals to 30 units. Okay? Thank you very much.